The axis of symmetry of a parabola is the vertical line, shown in red, that passes through the vertex and divides it into two halves. Here the vertex is at v-3 halves, -1.5, so the axis of symmetry is the line x equals -3 halves. The sum of the roots of a parabola is equal to -b/a. The average of the roots gives us the axis of symmetry, which is -b/2a. The product of the roots of a parabola is equal to c/a. With the sum of the roots, their average, and their product, we can fully derive the quadratic equation. The roots of the parabola are equidistant from the axis of symmetry. The axis of symmetry is given by x equals -b/2a. The distance between the roots is the absolute value of x2 minus x1. The product of the roots is denoted by p. The two roots are positioned symmetrically around the midpoint, s/2, separated by half the distance. The products of the roots is now rewritten as. This yields, using the difference of squares identity. Now we isolate the distance over 2. So the full distance between the roots is twice the square root of s/2 squared minus p. The sum of the roots is denoted by s. Rewriting the sum to express r⁻², in terms of r⁻1. Remember that the distance between the roots is twice the square root of s/2 squared minus p. Now we substitute r⁻2 with s minus r⁻1. Simplifying the equation and solving for r⁻1 gives the formula for the roots. Substitute the expressions for s and p in terms of a, b, and c. This yields the quadratic formula. The first root uses the plus sign, and the second root uses the minus sign. Congratulations! You have derived the quadratic equation based from the geometrical facts of the parabola. We now solve the quadratic equation by factoring. We are looking for two numbers that multiply to give 6 and add to give -5. Those numbers are -2 and -3. We then set each factor equal to 0 to find the roots. Solving each equation gives the two solutions. X equals 2 and x equals 3. Let's start with the equation x squared minus 5x plus 6 equals 0. We will solve this by completing the square. First, subtract 6 from both sides. Now take half of -5, square it, and add it to both sides. Simplify both sides of the equation. Now take the square root of both sides. Solving for x gives us two solutions. Let's start with the equation x squared minus 5x plus 6 equals 0. Here, a is 1, b is negative 5, and c is 6. We apply the quadratic formula. Substitute the values of a, b, and c. Now simplify the expression. This gives us the square root of 1. So the two solutions are x equals 3 and x equals 2. Take the derivative of x squared minus 5x plus 6 to find the vertex. Set the derivative equal to 0. Solving gives x equals 5 halves. Let x equal 5 halves plus or minus d. Substitute into the original function. Expand each term. Simplify the expression. Set the expression equal to 0. Solve for d squared. Take the square root of both sides. Now substitute d into the earlier expression. The two roots are x equals 3 and x equals 2. First, let's consider the general form of a quadratic function. The discriminant is given by b squared minus 4ac. If the discriminant is greater than 0, the quadratic has two real and distinct roots. If the discriminant equals 0, there's exactly one real root. If the discriminant is less than 0, the roots are complex. For our specific function, a equals 1, b equals negative 5, and c equals 6. Substitute these into the discriminant formula. Simplify the expression. The discriminant is 1, which is greater than 0. So we expect two real roots. Take the derivative of x squared minus 5x plus 6 to find the vertex. Set the derivative equal to 0. Solving gives x equals 5 halves. Let x equal 5 halves plus or minus d. Substitute into the original function. Expand each term. Simplify the expression. Set the expression equal to 0. Solve for d squared. Take the square root of both sides. Now substitute d into the earlier expression. The two roots are x equals 3 and x equals 2.